Welcome to this video on solving index equations. So we're going to look at a number of different ways to solve equations that involve indices and logs. So we're going to look at quadratic index equations. We're going to look at simultaneous index equations. We're going to look at systems of index equations, and they will be quadratic. So let's take our first example. So it's a quadratic index equation. So this is the kind of form that we've seen come up before. So we have 2 to the power of 2x plus 2 minus 33, 2 to the power of x plus 8. So you may notice here that we have a 2 to the power of 2x. Now I know there's a plus 2 there, but we have a 2 to the power of x, and then we have a number that doesn't have that. So this is going to form a quadratic. Now before it does that, we're going to need to do a little bit of work. So let's get to work. First thing we're going to do is we're going to split this out. So it's 2 to the power of 2x multiplied by 2. Now, so if you are using your rules of indices, which appear on page 21 of your log tables, the first rule in the first column basically tells us if we have two bases that have powers and they're multiplying together, we can add the powers. So we've actually just worked backwards on that. We have powers that are being added together, so we can say that's the same as 2 to the power of 2x and 2 to the power of 2 multiplied together. So then we have minus 33, 2 to the power of x plus 8 equals 0. So we're not there yet. Now the next thing I want to do is I'm actually going to do the 2 to the power of 2, which is 4. I'm going to pull it out in front, and I'm going to change this bracket to be 2 to the power of x and multiply and have that to the power of 2 as well. So if we're looking again at our log tables, page 21, we're working with the third rule down in the first column. So a to the power of p to the power of q is the same as a to the power of pq. So where the indices are being multiplied together, they can be split out using brackets. I've just again changed my order there. Then this stays the same, 2 to the power of x plus 8 equals 0. Now at this point you might notice that we have a quadratic. We have 4 of this thing squared minus 33 of this thing plus 8. So once you notice this and we have that idea of a quadratic, to make our lives easier, we're going to let y equal 2 to the power of x, so that thing that I've highlighted in green. So that becomes 4y squared minus 33y plus 8 equals 0, and hopefully now you can really clearly see how it's quadratic. So if you want to use, we'll use the guide number method here to help. So the guide number in this case is plus 8 multiplied by plus 4, which gives me plus 32, and we're looking for the factors of 32 that will give me minus 33. Now since it's a plus 32, the signs are going to be the same, so it looks like we're going to use 32 and 1, and both will be negative because we wanted to add to minus 33. So we have 4y squared minus 32y minus 1y plus 8 equals 0. So we take out 4y and we're left with y minus 8. We take out minus 1 and we're left with y minus 8. So that leaves us with 4y minus 1 and y minus 8 equals 0. So y equals a quarter, or y equals 8. So we have two answers there for y. So just be careful because we're not finished, and the reason we're not finished is they did not ask us to solve for y, they asked us to solve for x. So we go back and we say we know y is equal to a quarter, but we also say that y is 2 to the power of x. So 2 to the power of x equals a quarter. Now we're going to have to solve this as an indice equation. So the first thing I'm going to do is I'm going to have to write everything as the same base, the same big number. So I can write 4 as 2 squared. Now using the rules of indices, so it's the fifth one down in the first column on page 21, says I can write this 1 over 2 to the power of 2 as 2 to the power of minus 2. Therefore, x equals minus 2. So that's our first answer. The next answer that we have is going to be y equals 8. So now we have 2 to the power of x equals 8. So 2 to the power of x equals, and I can rewrite 8 as 2 to the power of 3. Therefore, x equals 3. So that's our two answers here. I'm just going to box them up so they're really clear. So what we're doing is we're rearranging this so that it looks like a quadratic, and we use substitution to make the sum easier for us to deal with. When you use your substitution, just be very, very careful that you go back and actually finish the question and answer the question that was asked and find the number that you were asked for. So, example number 2 now, it's a simultaneous equation. Now, this looks a bit nasty. This comes from a mock, but quite straightforward as we see it, because it just ends up as quite a simple simultaneous equation. So, first of all, like any simultaneous equation question, let's just label the equations. So I'm going to deal with equation 1 first. So 2 to the power of x by 2 to the power of y equals 8. So using my rules of indices, and I'm looking at page 21 in the first column, this becomes 2 to the power of x plus y equals 8. Now, remember, if you're solving an index equation, your aim is to try and get the base, so the big numbers, equal to each other. Now, I can rewrite 8 as 2 to a power, so I get 2 to the power of x plus 3 is 2 to the power of 3. Once I get that, I can ignore the base numbers. I can say that, therefore, x plus y equals 3. So I have a new equation, but this equation looks a lot more straightforward. Now I'm going to deal with equation 2, and I'm going to use similar methods. So I have 25 to the power of x over 5 to the power of y equals 5. Like in the last question, we're going to aim to get all the base numbers the same. So we have 3 in this case. Now, 2 of them are already 5, so let's get the third one as 5. I can rewrite 25 as 5 squared, and that's to the power of x over 5y equals 5. I'm going to use what is the third rule in the first column to multiply out the top line. So it's 5 to the power of 2x over 5 to the power of y equals 5. Now I'm going to use the second rule on page 21, which says that it's 5 to the power of 2x minus y equals 5. Now, when you get them to the same base number, we can ignore the base. Remember that if we don't write anything, it means a power of 1. So therefore, this equation is 2x minus y equals 1. So my new simultaneous equations look like this. Equation 1 is x plus y equals 3, and equation 2 is 2x minus y equals 1. So let's work on our simultaneous equations. The y's will straight away cancel. We're left with 3x equals 4. So x equals 4 over 3. Let's go back to equation 1. So we have 4 over 3 plus y equals 3. So y is equal to 3 minus 4 over 3. So y is equal to 5 over 3. And that's our two answers. So we have our answer for x, and we have our answer for y. So we were just using what we know about index equations to try and get all the base numbers to be the same and to simplify it down into two base numbers, because once we get that, we can ignore the base numbers and simply work with the indices, and that allowed us to create some very straightforward equations that we could work with simultaneously. Now, this is another question from the mock, and it's actually got three parts. Now, just for space-wise, I've split them over 3 slides. So if you are working through this with me, I would say do make a note that this is part A, and when we move on to the next slide, it will be part B. So I know this is not technically an indice equation. However, the next step, or the next part of it, is an indice equation, and the third part is actually a logarithmic. So there's logs in it. So let's deal with this one first. So they've asked us to solve this equation, x plus 1 over x is equal to 10 over 3. Now, this really sits in the algebra sphere. However, I will say you should recognize that when we have an x and a 1 over x, it will always work out to be a quadratic. So to get rid of the fraction, we're going to have to multiply each piece of the equation by x. And when we do that, this x's will disappear, they'll cancel, so we'll get x squared plus 1 is equal to 10x over 3. Now at this point, there's a second fraction, so we probably want to get rid of that as well. So let's take a look at that. So that's multiply all bits by 3 to allow us to get rid of that fraction. So we get 3x squared plus 3 is equal to 10x as these cancel. So let's rearrange. So we get 3x squared minus 10x plus 3 equals 0. So we're going to solve this, and I'll use the guide number here. So the guide number is going to be plus 3 by plus 3, which gives me plus 9 as the guide number, meaning the signs are going to be the same. So some factors of plus 9 will give me minus 10. It's going to be minus 9 and minus 1. So we get 3x squared minus 9x minus 1x plus 3 equals 0. 3x is common. X minus 3 minus 1, x minus 3 equals 0. And we're left with 3x minus 1. X minus 3, and that equals 0. So we're left with x equals a third and x equals 3. So there are two answers. So this is really, really important as we move into the next step. We're going to require both of these answers. So they've told us in the question the only limitation is it's a real number but not 0, and that is because you cannot divide anything by 0. So the fact we have 1 over x here means that x could not be 0. So that's the only justification that they've made. So let's look at part B then. So use your answer from the previous part to solve this equation. So you've been told quite explicitly that you're using the previous part. Now what you hopefully will notice is that all they've done is they've replaced their x with 9 to the power of x. So they've replaced x with 9 to the power of x. So our answers for x in the previous part will now be our answers for 9 to the power of x. So we have 9 to the power of x equals a third, and we have 9 to the power of x equals 3. Now we're back to simple index equations, which means that we need to work to get our base numbers the same. I can write this as 3 squared, and that is equal to 3 to the power of minus 1. So to that rule that I'm using there is the fifth rule on the first column on page 21. So I get 3 to the power of 2x. So the rule that I'm using there is the third one in the first column, 3 to the power of minus 1. I can ignore the base, the big numbers, and say 2x equals minus 1. So x equals minus a half. So that's my first answer. So let's work with the second answer. So again, I'm going to change this to 3 squared, and that equals 3. Remember, that's 3 to the power of 1. So that's 3 to the power of 2x is equal to 3. So again, we're going to ignore our base numbers, and we get 2x equals 1. So x equals a half. So they are our two answers that we get from this part. Okay, so we get x is equal to minus a half and x is equal to a half. Okay, so part C of this question says, hence or otherwise solve the equation log to base 3 of x plus log to base x of 3 is equal to 10 over 3, where x is greater than 1. Okay, so the first thing that you'll notice, and it's one thing to really do look out for with the logs, is that we actually have two different bases here. So what we're going to do first is we're going to change one of these. Now, I'm going to change this one here, log to base x of 3, and I'm going to change it so that the base matches the first log, which is 3. So if you go to your log tables, the very last formula given on the right hand side is given as log to base b of x is equal to log base a of x over log base a of b. So in the log that we have, this is our b and this is our x. So subbing that in, we have log. Now a is the base that we want. Okay, so we want this to be base 3. So it's log to base 3 of 3 all over log to base 3 of x. Okay, so the top line can be simplified just to 1. So if you want to put that into your calculator, and then the bottom line is log to base 3 of x. So if we go back to our equation, we then have a log to base 3 of x plus 1 over log to base 3 of x is equal to 10 over 3. So now we're back to a very similar looking equation that we had in part A. The only difference is instead of x, they've now put in log to base 3 of x. So we're going to use our answers from part A, and we're going to then state that each of these logs, so this is where there was an x in part A, and this is where there was an x in part A. So instead of having to work it out, we already know, well, if we substituted a y in for that, we would work out that that would equal 3 and a third. So let's first of all log to base 3 of x, let's say that that equals a third. Okay, so we're using the formula at the top of the right hand side of the page to work out what that means or how that looks as an indice. So we have 3 to the power of a third equals x. So x is equal to the cubed root of 3. And that's one of our answers. The second answer, we're going to have to work out using the second answer we got in part A, which was 3. So this is 3 to the power of 3 is equal to x. So x is equal to 27. Now, just double check, they told us that x had to be greater than 0. So when you check the cubed root of 3, if you want to do that in your calculator, it should work out about 1.7. So that means that that answer is absolutely fine. 27 is also greater than 1. So both of those answers are valid. So although this kind of looked like quite a nasty question, once you had the first part, which was a quadratic, just written in a different form, it was quite easy to work through. So do keep an eye on questions where it says hence and where they're linking one part with the other.